So in this video, I'm going to be explaining the final schematic for my valve-based filter. Now, this is just a low-pass filter section that I'd drawn out, just so I could plan scaling for when I drew the final schematic. Now, this is the input stage that I showed you in the previous video, as well as biasing the full triode ladder, the CV input, the output stage, and the resonance path. So because they were all broken down into chunks, I was able to explain it quite well there, but now you'll be able to see how it's actually laid out in the full circuit. So there is the CV control, as I mentioned, connected to all of the grids, allowing for very easy control over the impedance from the triodes and therefore the filter cutoff point. The other point was also the clipping diodes. I was very easily able to add and remove them as I pleased to increase the clipping of the circuit. And then the input and output stage remained completely unchanged from my original hybrid circuit, allowing for very easy implementation. Now here is the full final schematic. This was the low pass section and this was the high pass section. You can see, as I pointed out in an earlier video, the difference in how the input signals are connected. In this case, for the low pass filter, the input is actually connected into the bias voltages, which go round to the positive and negative bias of the ladder. In the high pass case, the signal is biased. There is a continual bias over the entire triode ladder, and the input goes into the center capacitor of the triode ladder. I did also create a components list, so I'd be able to start sourcing components for this when I got round to it. And you can also see here the switching that I'd talked about in the other video with the bypass and the series parallel switch. So I'd be able to have band pass, high pass, low pass, and band reject. Now, I ended up completely rejecting this filter design, and there are a few reasons for it. The most prominent is I made a slight error when I was actually planning this out, and I talked about this in an earlier video. And it's that triodes need an activation voltage of about 12 volts. A diode, just a basic simple diode, however, that requires about 0.7 volts. So when you're plotting out your biasing voltage, because it's so much smaller, you don't have to think about it quite as much. And I forgot to consider it quite as greatly as with the triodes. So because I have 6 triodes all connected in a ladder, rather than needing a 12 volt bias, I'd actually need a 72 volt bias, which was far too high for what I'd be able to supply it or for what the op amps would be able to handle. So from that alone, I wouldn't be able to use this filter specifically. I could maybe get away with just 2 of the triodes, or run the whole thing at the lower voltage that I was able to supply. However, this means that I'd be running them at because I'm running them at a much lower voltage, they have a less stable control curve. So with the way that they are controlled, you'd have your voltage and your current. So this is just the curve for a diode vacuum tube rather than the triode. They're very similar, but the plate voltage also has an impact on it. I mean the screen voltage, sorry. But you get a curve similar to this. And when you're running it at the much lower voltages, it's less linear and it can have defects in it like that, for example. So rather than getting a smooth filter curve, you can get a more distorted and harder to control signal, which can make it less favorable for the actual circuit. One of the other issues with this was the actual cost of the triodes. So in an earlier video, I've mentioned that I can get a triode pair for about £15 each. So that means I'd need a total of 6 of those for this full filter, which would come out at about £120, which was far too much for this single module alone. So I completely scrapped that as well. But other than that, hypothetically, this filter would be able to work at these voltages. I recently discovered that in Volstad, you can test with triodes. You can actually implement them into your circuits. So I do plan on going over and actually recreating this there and seeing if I can get it to work in that program. But that'll be something I do after that I've finished my EPQ, as this isn't something I plan on coming back to for this project. But I think this concludes the overview of this schematic and why I chose to not use it in the end. In the next video, I'll be planning more about, or I'll be explaining more about what my plans to replace this are, and potentially plans for the rest of my artifact.